So this is for temperate climates that have winters. It's not for north of the wall. You will need some other separate education if you want to get licensed in Alaska. We don't do that thing.
Yeah, Alaska, Canada, if it has permafrost, you may, well, yeah, if it has permafrost, this won't fully cover everything you need to go through. I'm going to say I've worked in North Dakota, and there are areas that I don't think any of it has year-round permafrost anymore. So,
yeah. So let's see. Engigma.com. We will be putting a quiz and reference guide on our website, engigma.com. Link in the description. Go there for your PDHs. And while you're there, it's a great place to make some connections, to do some remote work, because this cold climate stuff, it's a lot better to sit on a beach and design for cold weather than it is to sit in cold weather and design for cold weather.
Yep. I have a preference for Mai Tais from a warm beach in the cold weather if I don't have anything fun to do, if I'm actually just working. So yeah, again, shameless plug, but one where, hey, you can get your free PDH covered. Visit Engigma.com. You can sign up for the free PDH, or you can sign up to also view our marketplace currently. And it's a slow grow, but we're growing. So
yeah, we want to make your life better.
We're working
at it. Flexibility increases your happiness. We want to help.
We're here for engineering and technical sources. That's what we're about. So
yeah. So the technical issues. So starting out, project planning. So the first thing is, if you're going to develop a project, design a project that's in a cold climate, identify that you're in a cold climate and consider that. So one of the big things is scheduling. When you have a project, try not to build it during the winter. Things won't go as smoothly for you, and it will cost more.
Yep. And I guess something that should be stated or noted here is part of the reason we even get to have a course like this is because a lot of companies are going away from winter building moratoriums or moving away from being as reasonable about, hey, it's the middle of winter, this is going to affect our actual construction times and go live dates. So having some knowledge here to effectively know what you're talking about, or at least have an idea of, hey, we need to plan for this, is really important. So while you're scheduling to avoid, you're also we're going to also try to give you the tools to, like, oh, hey, this is how much longer things should take in this kind of weather.
Yeah. So it's not always just construction. One of the things that you'll face right away is surveying constraints. And this is not necessarily a no-go for surveying. A lot of surveying happens during the winter, because your survey crews during the summer are so busy doing construction staking, they probably aren't going to, they're not going to get to your topo and legal survey as quickly as you would like in the summer. It's going to get backburnered because everything's important, and your project isn't urgent at the time because the contractor that only has to give 48 hours notice is the urgent piece there. So a lot of your surveying is going to happen during the winter, actually. A lot of your topos are. And so if you're putting together a multidisciplinary project team, listen to your surveyors. Surveying is generally a local item. And if you are in a southern climate and not used to working in a colder climate, your gut check on your survey numbers is going to be different. So you can discuss that with your surveyor, but I recommend against changing their proposal numbers because you think it should be less, because it might not be less. They'll be out in the winter, so you have a few items that are going to be constraints. One is when you're getting your flow lines for culverts, they have to dig out those culverts. They have to dig out flow lines of the ditches to get the shots. That takes time. Another issue is it gets dark earlier and just the days are shorter. So you might have a survey crew that works 12-hour days all the time, and that's great. They normally are willing to do that. And they do 12 to 14-hour days here in the summertime, but in the wintertime, you don't have more than 8 hours of light. So they're driving in the dark and surveying up to 8 hours maximum.
And something to note with that working in the dark is that doesn't just affect your survey. It's going to affect all your work going on in the winter months, especially with the fact that a lot of municipalities, a lot of locations are very restrictive on use of construction and roadway lighting. So yeah, they might have the ability to do that work and they might have the tools to get it done with lighting tools, but that's a whole nother it's a whole nother issue that doesn't involve the technical side that you can run into with using those kind of numbers, especially deep in the winter. You know, right now it's February where we're at. We're kind of coming out of those deep winter months, and yeah, the crews that are out and active are definitely not working 10, 12-hour days right now.
Yeah.
So again, just something else to be cognizant of is that, yeah, or when they are working those long days, they're spending early parts of the days doing jobs that can be done inside or in lit areas or, you know, yards, buildings, things like that. So again, it will affect all facets of construction.
It definitely will. Another issue you're going to run into is battery life. Your data collectors, your rovers, your base stations all have a shortened battery life because of the cold. And sometimes they might not even work in the cold. When it gets, I don't know, I'd say sub-zero, generally most stuff is going to not function properly. So go ahead.
Oh, I was going to say another thing with that that'll come up a little bit later in this discussion that we don't, where we're kind of working through our outline that I'll add is that a lot of your material installation is temperature sensitive. Now, what I mean by this is, let's say you're working on anything with structural steel or welding. Now you think, oh, well, we can weld it in most temperatures. When you move into northern climes and you get into, especially with some of the very interesting, basically Arctic downdrifts we've been getting in the last 5 to 10 years, we've always gotten them, but we see them really commonly now. Without specialty tools set up in the field, it will get cold enough that you cannot weld, that you cannot use compression tools to fit aluminum pieces together, that you cannot use certain types of grease, certain equipment's not going to start. It basically, there's a level of cold where you really can't do much. You might be there for 8 hours, but you're going to get 2 to 3 hours, or you're going to be a smart contractor and say, it's too cold to work. We're not working today. We're applying for weather days. Here's why. So again, knowing those material constraints on your project, specifically where they're going to be welding, working with, you know, aluminum compression, or any sort of tool or process that has a temperature minimum that you have to be above, be aware of those things.
Yeah. And then One other issue too is the machinery doesn't start and so on. It's also really cold for the people working.
Yes.
They need to take a lot more breaks and warm up, because at some point your hands just don't work. And so you can't do the work. No matter how tough they are, it just is impossible.
And I'll say that something you're seeing, especially with I see that we're getting a lot more, I'd say, professional representation among field crews as time goes on. As in, you know, it's becoming a little bit more representative of a lot more profession-based workers are in the field. They're smarter about this stuff, and they know when it's too cold. And again, like I said, your good crews, your good contractors are going to apply for weather days rather than go out and work on days when it's 30, 40, 60 below zero Fahrenheit out there, because they already know that they may be better off, or they are better off, not firing up those rigs and not doing and waiting till it, you know, gets above whatever that temperature threshold is for the work that they're doing. So again, very important in project planning, to, especially if you're new, there's a lot of really good weather analysis tools. If you know what that breaking temperature, you know, breaking point temp should be, make sure that you have a buffer in your project planning that is close to that number.
Yeah, sounds good. So I think we can move on to design considerations.
Okay.
Sound good?
Yeah.
I have a rather large section on roads because it's what I know.
Yep.
So, you know, a few of the design considerations, thinking about that, is one is your super elevations. If I remember correctly, I don't have a green book at hand, but they'll show values of 6 to even, I think, 8% super elevation. And that doesn't work in places that get icy. You'll end up with a pile of cars at the bottom of your curve. And so a lot of times you're looking at limiting your super elevation to 4 or 6%. Normally your road design manuals from your applicable DOT will have that guidance, but that's something to make sure that you check on if you're designing in a different state, rather than going by strict or by just AASHTO.
Yeah.
Another thing, at least in South Dakota, that we do is we flatten the back slopes on the upwind or upwind of the road compared to prevailing wind. So north and west, the ditches will be, or sorry, the back slopes will be flattened to a 7-to-1 instead of a 5-to-1. That's to provide some extra snow storage in your cut sections. And it seems to help.
And I think something to mention here, and this is specifically for the central United States, is if you're from an area outside the central United States and we talk about prevailing winds, just know that, again, it's a very important design consideration in cold weather conditions, because we get a lot of winds. Generally, when you're in less mountainous, out on the edge, or less mountainous central US, you get a lot of heavy continuous prevailing winds. And then as you move towards the Rocky Mountains, you get lots of very interesting, very destructive wind properties. You know, I would say outside of the Rocky Mountains on the plains, but near the mountains. So again, just it's a real design consideration to know what wind issues you may run into in the central US. Definitely worth noting that that is something you should know and understand, or if you don't, tap local resources to kind of break it down for you.
Yeah. And if you are really lost on where the prevailing wind is, you need something that's fairly exact. Check the local airports on Google Earth, and the runway is pointing at the prevailing wind.
And I'll also say that meteorologically speaking, they do a great job with winds and prevailing winds on pretty much any meteorological service.
Yeah.
So, take your pick there. It's the one thing I will say 95% of the time they're right on. So probably even more. So that will give you, again, using those kind of tools, if you ask them what the prevailing wind is, it's not like, asking them what the weather is going to be like tomorrow, where it's 50-50 chance and they still get to keep their jobs. No, they generally are very accurate when it comes to prevailing winds.
Definitely. Next item I have is raise your grade line above your upwind catch point. So you may be in a small cut section for a lot of the road, and that's great. You might need that to balance your earthwork quantities, but it's probably going to be worth raising your center line or your grade line up to match or be slightly above that catch point, and doing a special ditch grade instead of your standard ditch grade. And if you have a shallow ditch, you'll just end up with drifting that will fill in the ditch and drift across the road right away. Where you're better off if your roadway center line is the high point, and then you'll have your downwind lane starting to drift, but generally your downwind ditch will be full instead of your roadway.
So question, kind of, not totally related to that, but we're talking about roads.
Yeah.
And this is for you, Kyle, around what kind of, especially with concrete, what kind of finishes should we be looking at in our concrete for northern areas? Huh?
Throw the trowel away.
And that's, what kind of roadway finishes are generally used in northern climes that you may or may not see, when you move further south, or where they don't have the freezing issues?
Yeah, we still have a lot of the tined finishes. Also, a carpet drag or burlap drag sort of finish is pretty common, especially like bridge decks.
Yep.
So, yeah, pretty much, it's that fine line between having too deep of texture that you'll catch water and have more freeze thaw issues versus having no friction. Something else we see actually quite a bit locally where we are is the high friction epoxy chip seal.
Okay.
We've been doing those on, well, we have plenty of curves that don't meet design speeds.
Yep.
So it's a way to mitigate that. But they've also, I believe, been using crash data to determine locations for this high friction coating. And that really does seem to work pretty well. I've also seen the stone matrix asphalt overlays used quite a bit. And I know just from driving on them, I can feel a difference, and it provides, after the first year it's down, it provides a lot more friction on your driving surface. Yeah.
And again, that's just something to take a note. They're using high friction finishes that don't allow a large depth of water to hold on the road, because you'll experience more freeze thaw damage to that finish if it's too deep. Correct? Is that a good?
Yes, yeah. That's correct. Okay. Yep. I'm going to add something in my stuff for later. Actually, now would actually be a good time for this. So it wasn't in the agenda, but we'll add it now. This is worth talking about.
Okay.
So you're reinforcing steel and bridge decks because of the need for friction and the challenges in having a surface that meets the criteria of being smooth for water but not for tires. You end up using a lot of de-icing chemicals, salt, mag chloride, something like that.
Yep.
So a lot of times you're going to see a lot of epoxy coated rebar in your bridge decks. I think that's pretty common everywhere, but definitely want to watch for corrosion and minimizing that corrosion in your structures that are either roadside or roadway structures.
Yeah.
I guess here we also epoxy coat the dowels and the tie bars in PCC paving.
Yeah, I think I've even seen them coat like saddles.
I think so, yeah.
Yeah. So again, they won't allow for exposed metal on anything inside of your bridge deck concrete.
Yeah.
And go ahead.
Oh, well, I think that there is some bare steel allowed in substructure of bridges, but this entire superstructure is going to be all epoxy. Entire roadway is all going to be epoxy coated.
Yep. But again, something to be aware of that is, and I think the way to look at it is because of the weather cycles in most places in the central US and the use of mag chloride and salt, what happens is it becomes, I don't want to say like an evaporate in the air, but it definitely, the very, very fine salt particles, because it's all various forms of salt, whether it's magnesium chloride, sodium, whatever salt they're using, and it coats everything. And when I say everything, if you've ever owned a vehicle in any of these places, you'll understand. If you don't, well, I think we can take there's enough vehicles sitting around. We can take a picture of what one looks like after a salting season.
Oh, we definitely can.
And so that's the same coating that's on your vehicles at home is also on everything around the bridge. The difference being that, most vehicle owners are pretty smart about it and will go off and wash their vehicles, after that's over. Whereas most bridges, pipe, whatever exposed infrastructure is out there, has to wait for it to rain. And if you get, between 4 and 15 inches a year, like a lot of these places do, it's going to be a while before it rains.
It is 4 to 15 inches includes the snow and ice.
Yes. So again, it's good to note that when we say, it's road salt, out here, that doesn't mean it's going to get washed in 4 or 5 days. It usually means you have months at a time, especially is that after you come out early spring, late winter is definitely a dry season in most of these areas. And then once you get into mid-spring, that washing finally does occur. So again, another thing to be aware of.
I mean, it snows in May, so.
Well, you know what I mean.
Oh yeah, September through May, we get snow. Yeah. So a fun fact about the salty vehicles is if you drive it through a place that might happen to have bison around, they will use your car as a salt lick. Fun times.
Yes.
So let's see. Next item on the agenda is flatten your intersections. So all of the newer ADA, or let's see, the most recent update of ProWag has a requirement to flatten out your stop controlled intersections or your crosswalks anyway. So that really results in your intersections being flattened. However, your traffic queue ends up being steeper because of that. So in cold climates, trying to plan your traffic along with your grade line, it's a good idea anyway, but it's especially important in cold climates, because if you have a signal or a stop sign on a hill, at the bottom of a hill, basically anywhere where your roadway slope, I would say about 5% or more, you're going to have issues with people either not making it to the intersection, not being able to go after they stopped, or going the other way. If they're coming down into the intersection, they aren't going to be able to stop, and you're going to have a higher accident rate.
Yeah, and I think there's some really good, I mean, I know locally there's a lot of good examples of how this has been done well and poorly.
I can think of more poorly than well.
I think I think a good example is the base of and we can cut this if we need to, but the base of Catron Boulevard is a good example where they have managed to level out quite a good way behind it, even though it's a larger hill. And then the top, same thing. They've done a pretty good job overall of not putting any sort of signal or roadway intersection on a hill. Now, poorly, there's a ton of examples, but I thought that was a decent one of like, oh, hey, they did. We'll give them the pat on the back that they did this one right. But really important. Again, if you've ever lived in an area that suffers from cold weather, every single cold weather area has at least that one stoplight in their town that was definitely not designed to that particular standard, and everyone knows that it's just not a good place to be in the winter.
Yeah, for sure. I think we can probably move on to this next topic here.
Yep. So frost depth.
Frost depth, yes. I was looking through it. I was thinking IBC had a map. I know they reference it. Just doing my research before this, I think National Weather Service has plenty of information. But overall, let's see. So I guess side note, when we were looking at the poll, the geotech recommendations or the geotech spec for polls, I was thinking that there was a map included in there. I don't remember the source of it.
Okay, and I know that there are maps. What I'll say is, generally speaking, areas that have what we would consider normal, for the purposes of this discussion, frost layers, it's generally 5.5 to 6 feet is considered adequate burial depth for most infrastructure types that include water.
Right.
To avoid frost heave and other issues, most other infrastructure types, it's recommended you get at least 3 to 4 feet down. Frost heave happens in all these places. You get movement as you go through freeze thaw cycles.
Sorry, go ahead.
Oh, go ahead.
Oh, I was gonna say there's some potential to mitigate that. I would say that those freeze thaw or the frost heaves are the bane of everybody's driveway's existence.
Yeah.
And I've seen people throwing away all sorts of money to repave their driveway. Oh, it's cracked and it's heaved. And so they get a new driveway poured, and it happens again because they didn't take any precautions of, I've seen recommendations for insulating the ground. I think that would work. Definitely digging out and going to a granular material. But overall, some stuff you just have to live with.
I think a good rule of thumb for, I'm going to go with infrastructure and higher budget projects, is the material you place on top of or in the ground is only as good as the material around it. And generally speaking, a large amount of engineered fill is required to prevent that sort of frost heave. And when I say a large amount of engineered fill, I mean a large amount of properly installed and spec'd engineered fill, not just the first gravel product that you go and pick up at your local, at your whatever local gravel pit you've got nearby. So again, that's extremely important in all design, but especially when you get into areas with a really heavy freeze thaw cycle. You know, I know some examples that I've seen locally. If you've got a heavy item on a large pad, you either have to put in a huge spread footing, or you have to put in, like, I don't know how many, I believe the over excavation is like 3 times the size of the pad minimum. And then
Right.
incorrectly installed engineered fill. Again, when it comes to frost depth, you're going to fight it. The same goes with if you're installing things like water mains, even PVC pipe that you just don't want to have any breakup or anything enter into that pipe. Don't allow native backfill, because native backfill is what's going to cause your frost issues in those kind of installations, unless you're over that 5.5 to 6 foot depth.
Right. And something else is to design with higher velocities in your systems. So if it's a water system or if it's a sewer system, your higher flows, your higher velocities are going to function better if you can't get your cover depth. So that's not to say, hey, downsize your pipe if it's shallow. That's I guess, try to get your cover depth. And if you can't, make sure you have a good steepness on a gravity system, or some looping in place to where you don't have water just sitting in pipes.
And something else to be aware of with frost depth is it's a bit of what I would call an engineering nightmare scenario that I have run into, is fairly common in areas with alluvial bands, is the fact that, hey, did you know that high pressure rule also applies to just natural water that occurs underground? And that when you're working in the winter and you punch into those water sources, you now have unfrozen water that was not exposed to the elements at depths less than frost depth. And again, this is just a great demonstration of how you can really run into extremely novel problems in cold weather areas during the winter. And something you don't think of is a lot of times what happens in uplift is a deep alluvial band will get pushed almost to the surface of the soil, and it will push a lot of water through that alluvial band very quickly to the point where it doesn't freeze. So you'll find flowing water at the top of a hill. Again, is it every single hill you go by? No, but you'll find, especially if you're doing utility work, you're building towers for cell towers, things like that. People tend to like to give you the rocky hilltop as the location for your project, because it doesn't really serve any agricultural use and again, in most of the places where they're already looking to do those kind of infrastructure projects, the Rocky Hilltop is not where they're putting up the $3 million home either. So generally speaking, it happens more often than not that you find yourself in a really rough situation with underground alluvial bands when you get into hilltops in parts of the central US, especially when it happens in January or February.
Yeah. You know, the other fun thing with the utility depth and the freezing of pipes is it happens when it's the coldest. So then you have people that need to, well, one, you have users, customers, whatever you call them, without the utility service that you're providing them. And you have your utility crews, contractors, whoever is on call, digging in sub-zero weather. And so you have equipment that's not working. You're running into all of those same issues that we talked about earlier. Short days, equipment doesn't work. It's not really safe for the workers. And then also onto our next topic, which I think we can get in there, is the construction during the winter. And so you end up with, you can't place cold embankment, or you can't place frozen embankment. You can't pour concrete on frozen subgrade. Can't place frozen gravel, and you need to do something for your concrete to not freeze. And you have all of those in an emergency sort of setting.
Yep. And I think the best way I can put it is there's an entire cottage industry of rental tool providers who make lots of money on unplanned or planned projects that happen in the middle of winter.
Yes.
So if that gives you an idea of how much more expensive it is, that it can basically maintain a construction industry rental section subset.
We should go in the glycol business.
Yeah, right? Yeah, exactly. So again, you have winter construction is possible, but it's very expensive because of the short days and a lot of the specialty tools used. Kyle mentioned gravel. He mentioned installing concrete. He mentioned frozen ground. So something you see, especially in the north with concrete, are ground heaters and insulating blankets. Really, really common things you see. The other thing that you'll see, especially with substation and bridge building, are welding tents. Yes. Now, here's the thing about most welding tents, and this is where it comes into a massive safety issue. Almost every welding tent I've ever seen is a stick-built frame with some sort of lightweight plastic on the outside, and they're welding inside of this giant pre-built structure. Now, welders are professionals and they're very good at what they do, but when you come down to a safety evaluation, it's definitely an area of concern.
Now you have me rethinking some stuff going on some of my projects.
Again, if they're doing it right, you won't have an issue. And honestly, like, usually that material is so cold because of the outside temperature that they don't have to worry about it. But you have to also think of, you have to get that welding area, and this is where the time issues come in. Whatever work the area that is, if you have to perform work that is to be done at a required temperature, you have to warm that area up every day when you go to that job site, and until it hits temp, you can't work.
Yes.
So really, especially in your specialties or types of construction and assembly that require specific temperatures where you need tools like like big heated, basically tents or structures, you're losing half days.
Yeah.
Now, can it be done? Yes.
Yeah, you're losing half days, or you heat it continuously.
Yes, that is option B. And again, there's a cottage industry around it. It's a
Yep.
very expensive option. Generally speaking, most contractors, if they're smart, are going to either have a at-will charge option there, or they're going to just straight up charge you a much higher premium overall for your project. I will say for winter projects, in my experience, lowest bid options and contracts are a bad idea, because generally lowest bid options and contracts speak to the experience, either lack of experience or a mistake was made. Having been on contracts where I was handed someone else's work and the mistake was made, or having been undercut by people who don't have experience in the north. Again, something to be aware of. If you see especially if you're kind of a project management / engineering entity that's just starting to work in the north, and you see a bid that looks too good to be true for winter work, it is.
Yes. So for magnitude, this is about 8 years ago. I was on a project where we had to, for whatever some reason, project got delayed. It was a building project, somewhat small, a fairly small office building. I think it was around 5,000 square feet, roughly. So it was fairly small. We had a $30,000 change order for going from normal construction to winter construction.
Yep.
And I don't know if that covered it or not, but that's what the change order was.
Mm-hmm. And again, I think I have a great example of a winter project gone absolutely just as poorly as possible. Substation design for, I believe it was either for MDU or Basin. Built in I can't remember which town in North Dakota we were working out of, but we were in North Dakota. There was a mistake made on the bid. And of course, what happens? They execute the bid. We get the bid because we made a mistake and we put summer hours on a winter project. The first thing we encountered, and this is one of those great situations, we're on a rocky hilltop. We punched down, and roughly 3 feet under the substation yard is alluvium with flowing water in it. In the coldest winter that North Dakota had seen on record for like 15 years. It was -60 for most of that project. So you have, we also had to tent like 30% of the yard to do work for welding. And again, this is where material installation becomes really important in understanding your materials. At the time, we were installing some porcelain parts in the cold weather. So again, brittle material, extreme cold. One of our workmen broke off a porcelain insulator on a piece of equipment that had to come from China. It took 9 months. It got stuck in customs. Again, these are extreme examples of how wrong things can go, but had he done the same work he'd done in spring, he wouldn't have broken that piece off. It was fatigue, extreme cold, poor judgment on the guy's part. He's one of the better linemen I've ever worked with, actually, like long term. It was just, that was the nature of that job. And we were the low bidding contractor, and everything that could go wrong in a cold weather environment did. It's part of the reason I really advocate like knowing material properties, knowing at what temperatures you can do what work, because again, if you need to weld, you need to build tents. It needs to be so warm in those weld areas where they're working, or you need to get lucky and get some warm days. But either or, you're seeing project delays one way or another in that situation. And every material that you work with, at some point there is a minimum temperature for workability, and some of them we don't think about because we think, oh well, no one's going to work at that cold a temperature. And again, coldest winter on record that maintained -60 for multiple weeks. We pushed the limits of that, and we learned a lot of things that not even the folks who were from that area had really known, because you didn't see those kind of sustained temperatures over long periods. We probably should have spoken to some Alaskan or Canadian engineers to get a better idea.
The true north.
Yes, the true north of the wall.
That's right. So I would say that it's safe to summarize that as, when you're trying to do stuff in the winter time, you are setting a place at the table for Murphy.
Yes. And not only that, I think there's a lot of easy mitigating measures with winter work where it's not even an expectations or not allowing Murphy to exist, but it's definitely a, when things go wrong, it's okay, and there's ways to fix that. And winter projects definitely need to have safety net versus a summer project.
For sure. Sure. Let's see. So I think we've talked safety issues. I mean, let's see the items. So concrete. A lot of people deal with concrete a lot.
Yep.
Definitely one of the materials that needs some special care for cold weather. ACI 306R-16 is definitive source for that. I've seen that come up in specifications, and so the person that put following ACI 306R-16 in the specifications did it wrong. It's a guide, it's not a specification.
Yep.
If you want stuff out of that guide, you say in your specifications what needs to be done or what shall be done, not this is best practices. So make sure that you're not specifying to follow a guide. You give actual performance measurable specifications.
And this is kind of referencing again, it's been a while since I've done with ACI, but does that ACI guide include grout in that kind of weather?
I'm gonna pull it up here. I won't share it right now because I don't want to run into copyright. I think it's the cold weather guide to cold weather concreting. Okay. So I think it is just the concrete.
And I think it's just good to note that, like, any liquid substance you're going to use on a job site, again, concrete just being the most commonly, like by weight, especially the most common cold weather item you're going to see, you need to know what those temperature rules and limitations are. Because I think that's one that I see done incorrectly more than anything else on job sites, are when it's right at the edge of too cold to install grout, you see a lot of grout go in. And generally speaking, it just means you get bad grout, or, when you're up north and you're visiting Mount Rushmore or going to the Rockies or whatever, look at grout work in general, and you'll see a lot more ugly spalling or poorly executed grout work. And I think a majority of that poorly executed is because it's either too hot or too cold when it's installed. Those are the two conditions we like to get into out here. So again, pretty easy case studies for that kind of also are concrete is a great example because we have so many guidelines.
Yeah.
And there's a lot more rules and regulations around how that's done. But really, material specs are where it's at when it comes to knowing those and having those on hand and available for the people who will actually be doing the work in the field. Because that's usually the kicker with those types of things.
Yeah. A lot of times I see specifications, follow this guide. Did you provide it? Well, no. Do you know exactly what's in it? Well, no. So somebody on the last project put it.
Yep. So again, good general guidelines are just to know those things if you're taking on projects further north, like, and have a general idea of the weather conditions you're going to run into. The nice part is if you're subcontracting or working for someone, they can generally, even if you're don't know where to find that or it's not available, they'll find it for you or help you get it.
Yeah, certainly. Something else, just kind of a quick thought on that. It does talk about heating the mixing water, and I've worked for a company that had a boiler for the mixed water at a ready mix plant. You can get hot water for your concrete.
Yep.
So
again, there's an entire service industry based around cold weather construction. That should tell you what the cost differences are right there. If there's a cold weather service industry, that means there's money in helping execute cold weather projects. I'm going to say, generally speaking, most companies try to originate in about now, early to midwinter, get projects out the door and kind of ready to go in the spring and execute through the year. What we're seeing in industry and have seen, I'd say in the last 5 to 10 years especially, would be that cyclical construction periods or moratorium periods have really gone away for a lot of government entities, investor-owned utilities, people who are generally building large-scale infrastructure projects. We're not seeing those more winter moratorium periods like we used to, because it's become more important to execute capital in certain timelines, and basically the engineering and actual operational construction side is of less importance to those entities than it was in the past. So again, as you provide services for companies like that, there's often a really strong case to not build in the winter, but you're still going to have to figure out how to do it. is all I'm really trying to say here.
And on that note of the items being driven more by budget constraints, putting deployment of capital based on financial goals rather than doing something well based on engineering judgment.
Yep.
It's frustrating. And so if you're working in one of those industries where you're pushing out stuff that works, but it's not really a good idea,
let's go with
check out Enigma.com.
Yeah, is it optimal? Try Enigma.com.
Yes. We are all about empowering engineers. And over the course of, I'd say about the last 100 years, after a group of finance people went from the Pentagon to Ford, made it a finance focused instead of engineering and manufacturing company, all of corporate America followed suit, and they have been disempowering engineers ever since. And we want to give the power back to engineers. So join us.
Yeah. Yeah. And if you just want to join us for free PDH, that's okay too. We'll
That is.
You know, we don't, that's the other part of it is if you're not interested in all the other stuff, we provide free PDH. We provide a lot of free, we're working on a lot of free job development and personal development information as well. So these are all things that we're willing to provide to you for free because we see the value in providing it for everybody, whether or not they want to participate in our product or, you know, in our product and with us or not. So again, I like it.
One request on that, please subscribe to our channel. It'll help us out.
Like and subscribe. Yeah, there we go.
Yeah.
I had to put on my best YouTube voice for it. You need to like and subscribe. Hit the bell, please. I don't even know if we have a bell for joining the channel. Probably not. I have no clue.
I don't think so.
I don't manage our YouTube. I can't tell you.
So if you work in a place where you do not have freezing conditions, you likely do not air entrain concrete because you gain extra strength by not having air entrainment and you don't need it. Here, we need it. It helps protect the concrete from freeze thaw. Something else that's kind of a sub-bullet between that cold weather and the air entrainment is do not let your fresh concrete freeze. You need it to not freeze for like a week. Otherwise, it basically just makes it fail right away.
Again, a really common one you'll see if you visit areas up here are, you'll see the patio section that was obviously poured, or the walkway section, whatever, that was obviously poured at the end of the year after that section failed previously or during freezing weather, and the entire top has spalled away. Really common in like sidewalk construction or smaller construction around in northern areas. You see it all the time of hey, there's this one section of concrete in this walkway that is basically just like slowly spalling itself apart. Yeah, that's because they poured it in winter and let it freeze.
Yep. Something I see that I think it more bothers me than anyone else, I guess. You'll see basement floors that are poured in the wintertime and left unprotected. I'm not going anywhere with that. It just bothers me, and I don't like seeing it because it's weakening that floor, because interior floors generally are not air entrained. So that'd be one thing of when you're looking at buildings, watch for what you're speccing for concrete based on when the construction is going to happen. One problem you'll see though is if you do try to air entrain your interior floor, they will have some workability issues trying to trowel a concrete floor that has air entrainment.
Mm-hmm. I think that's another thing for folks to be aware of when it comes to mix design, is that the further north you go, and I think this is a broad statement, but I do think it is an accurate one, the more seasonal mix designs you'll find. And they're generally based on temp, relative humidity, and where, you know, how much freezing weather they have at the time. So again, another thing to be aware of, that sometimes, especially with somewhat interesting producers in some of these areas for concrete, you need to be aware of what the differences between those seasonal specs are, so you don't pull a summer specification in the middle of winter. So again, it's just another thing to be aware if you're working on projects up north. Don't just pull the concrete spec from the last project.
Yes, for sure. It looks like I have one more bullet item on here, and that's the weather disruptions. So in 2013, we had an interesting weather event in the beginning of October. We had about 3 feet of snow, and it melted in maybe a couple days. So our contractors had an interesting conundrum, I guess, if you will. And that is okay, well, we got the snow and then it melted in a few days. And so the weather days by specification didn't have a lot of time off for that, maybe a week or two. But then what happens is once that subgrade is wet and you're getting into shorter days, it's not going to dry out. None of your embankment's going to dry out pretty much until spring, that your contractor can end up, dirt farming all winter long with no positive results. And sadly, the people involved in this have been here for decades, so should know better. But anyway, that's one thing to, if you're a project engineer or project manager and you are working with a contractor to do a project, keep in mind that your weather disruptions in the fall are going to hang over that project all the way until completion or until the next spring and summer. And you want to be fair and reasonable. It's not an us versus them sort of thing.
And the item that I'll add to that is that usually concrete is either happening, in my experience, most concrete work is early project work. And delays in early project work more aggressively affect schedules and those sorts of things than in later project work. Again, I think we can probably, at the end of this, maybe provide some examples of like, hey, and even then, like, here's some things you might see in winter and summer specs, those sorts of things. But it does come down to, if you experience a delay in concrete work, it's going to equate to large overall project delays. Again, the first, they're usually first or second group on your site. They usually have the most time intensive early portion of your project. When stuff goes wrong there, again, the earlier in the project you have your issue, the more adverse its effects on your overall schedule. So again, just something to be aware of is that concrete is often, concrete and dirt work are usually where that happens.
Yeah.
And cold weather is not as detrimental on a lot of dirt work contractors in the north because they're used to it. And if they know when that's happening, they'll give you appropriate timelines. Concrete, no, you have to have the weather to do it. And you're kind of at the mercy of Mother Nature there to some degree.
Yeah. I guess the example I had was, I think, a city street project. I think you're probably referring to something more along the lines of a substation or a building.
Yeah, I mean,
concrete.
Even with the city street project, like,
yeah, your earthwork is the
earthwork outside of soft spot issues, which are something that we're not touching on in this, but well, I guess no. Let's touch on it with cold weather construction and soft spots in earthwork. Sure. I think it's another good construction item that we can touch on. Generally, what's going to happen is, and this is what I've found, and you can add to this, freeze thaw cycle with open earthwork is a project timeline killer, because you get soft spots because of the freeze thaw cycle, and those soft spots collect more water, and as they collect more water and freeze and thaw more, they get softer. So as Kyle was saying, you end up with a dirt farmer situation. I
Yeah.
mean, if you want to build on that statement, that's kind of been my experience with it in those types of projects, are that it's not good.
No, so I mean, really, your two ways to really have a project where you're working over the winter is you are, well, I wouldn't want to do large paving projects in the winter because it's not feasible to heat the ground that much. You can maybe do some intersection hand pours sort of thing for paving, where you can dry out a couple 100 feet length of road, or dry out, heat up with your ground heaters. That might be feasible. A lot of times you'll see removals happening going into the winter, and if they busted on a schedule and you have open subgrade going into winter, your best bet is to button it up somehow, either plastic sheeting or you get gravel on it and get it graded off, so to where even if you come back and salvage off the gravel to finish the embankment, but your embankment work's shut down for the winter, there's really just no way to go about it otherwise. So it's you race to get it buttoned up, whether it's gravel and maybe a prime coat. That's kind of your only options.
Yep. Yeah, I would agree. Just again, throwing it out there, is it's an issue that I know is fairly prevalent if you're forced into a winter construction situation. As you've said, you're better off to close up shop until the weather supports finishing that paving, rather than forcing something over the winter.
Or even just like a 1 inch or 2 inch asphalt lift, just to get waterproof, or like I said, a prime coat. Your asphalt cut back.
So I think we can probably do a recap and close it out, wouldn't you say?
I think so. I'd say the biggest thing is awareness. We talked about, how is it going to impact your project? Trying to work through the winter, or just plan on not working through the winter, which is probably the better idea. Some of the design considerations you need to have for your roads, considering your frost depths. If you are doing construction, how do you do that? And I think we gave a pretty good primer.
Yeah, I think know your ACI cold weather concrete guide, ACI 306 R-16. It's a guide, it's not a spec.
Yep.
Know your material specifications for the material you're using on your project. Those are provided by the manufacturer. I can't tell you what materials you're using. You need to have that data in your project file, and you need to know specifically operating temperatures for installation and use of certain things. You also need to know specific operating temperatures for certain jobs, like welding.
Yep.
Highly important. And you really, a good, and I hate using rules of thumb because they only turn out about 40% of the time.
Right.
But a decent rule of thumb would, just generally speaking, if you figure out what it would take in the summer and you add about 50% more in terms of labor, you're probably at least in the ballpark of what a winter project will take. Now, again, that's ballparking it. That's for if that activity can even be done in the winter. Also, utility depth, we covered. 5.5 to 6 feet for most areas that generally freeze.
I would say definitely check
Check with your local team on that.
Yeah.
I know where we're at, which is roughly the same, basically the same latitude as Great Lakes, New York. We're looking at 5.5 to 6 feet. When I worked in North Dakota, it was 5.5 to 6 feet, and they get a lot colder than we do.
Yep.
So that's to say that 5.5 to 6 feet is a very safe number.
Right.
Yeah, and otherwise, I mean, I think Kyle did a good job covering specifically what needs to be done in road design. Again, utility design is 90% knowing depth, and the other 10% is understanding that you're going to likely be paying a lot more for extra backfill in areas with hefty freeze thaw cycle. Other construction considerations, like I said, are mainly just there's a lot of time and effort involved to complete winter construction, and you're going to get pushed into it, I believe, more and more as we move forward. It seems to be an industry trend.
Yep.
I'm not for or against it. I just think making people aware that it is more costly and it is more time intensive to do so is an important expectation to set up front.
Right.